Yeah, so the next what we see is the vaporization. So how does kinetic theory or conversion of matter on basis of kinetic theory? So vaporization, in case of vaporization, what happens? The temperature increases of the liquid. Accordingly, particles gain energy. So as you see that the heat energy supplied in the liquid is absorbed by its molecules and stored as potential energy. It's the same thing what happened in the solids also. The heat energy was stored in the particles as potential energy. This potential energy, what did it do? It interparticle space increases. So stored potential energy increases the space. The stored potential energy is going to increase the space between them. Actually, why does it so happen? Because the potential is going to get converted into kinetic energy, and hence the motion is going to become more vigorous. इसीलिए अपने आप बाजू में जगह हो जाती है. So the intermolecular space increases because of the change in potential to kinetic, but it's not required to understand it in this particular part because they have not mentioned it. So we will not learn it. We can just understand it that. Why does that thing happen? How does the change take place? Because of the increase in the kinetic energy. So stored potential energy increases the space. Interparticle attraction decreases. Force of attraction decreases to almost negligible. The force of attraction here becomes negligible because it's already in a vapor state. It's in the solid, liquid state, and it's going to turn into gaseous state. And at boiling point, particles become free and the molecules become completely free and escape as gases. Opposite takes place when solidification takes place. On cooling solids, temperature falls, particles lose energy, and on cooling, the liquid potential energy in the molecules is released as heat energy. So potential energy which was stored over here is released as heat energy when cooling takes place. So on cooling, the heat energy is going to be given out by that particular particles as the potential energy is reducing. And as the potential reduces, kinetic energy reduces. So जो ऐसे movement था वो धीरे धीरे कम हो जाएगा. Automatically molecules come closer to each other. The closer they come, the force of attraction is going to increase. So that's the next point. Interparticle attraction increases. Force of attraction between particles increases. And at solidification point, at the point where solidification is going to take place, particles slow down, molecules are not in a position to be free, and the liquid changes into solid state. So this is how the melting, vaporization, liquefaction and solidification is going to take place as per kinetic theory of matter. Now we also see about sublimation. What happens in sublimation? How does the kinetic theory explain sublimation? Is on heating a sublimable substance like sodium or ammonium chloride, particles, see intermolecular particles जो है उसके अंदर is low. The intermolecular particle attraction, the force of attraction between particles is very low in case of sublimation. So sublimable subsolids have very low force of attraction between their particles. So because it is very low, that's why it doesn't take time to break over here. See, in case of solid, liquid and gases क्या होता था? Solid to liquid में थोड़ा break होता था, फिर liquid to gas में और थोड़ा break होता था, and then it used to escape. Why? Because the solid had got, when the matter which was made up of, it was made up of such things that it had got a very strong bond between the molecules. So वो bond को तोड़ते तोड़ते जाने के लिए time लगता था from solid to liquid and liquid to gas. Here already they given that the matter, that the sublimable solids, they have got a very low force of attraction between the particles, and due to that the breaking of that is very easy. और जैसे वो टूटेगा तो वो बीच में का लिक्विड स्टेट में जाएगा ही नहीं और सीधा गैस में होके भाग जाएगा. So interparticle attraction is overcome. So interparticle attraction is overcome very easily. So on heating a sublimable solid, the interparticle attraction is overcome, and the molecules break free and escape from the solid surface of the solid directly into vapor. So this is what happens during sublimation in case of, as per the kinetic theory. Now we see the last part of this particular chapter, and that is the law of conservation of mass and an experiment to evidence for that. Now the Antoine Lavoisier was one of the scientists who formulated this law on, and the result is the same, that if I take two substances, the reactants of any chemical compound, and I mix them or I react them, I get two different substances. It is seen that the mass of the substances before the reaction and the mass of the substances after the reaction is same. So we can easily, I don't want to take the examples of the NaCl and AgNO3 and all because we are not so much comfortable with those names. I'll make it very simple. Suppose there is a compound which is named as AB and there is another compound which is called as CD, and suppose we are going to react it such that A reacts with D and B reacts with C, and you get it over here as AD plus CB. So it is seen that the weight of this substances before the reaction, so these are called as the reactants. Reactants are those substances which are going to be used for the reaction, and these ones are the resultant, we are called as the products. So products are those which are formed due to a reaction. So it is seen that the weight of this is equal to the weight of this. Okay? So whenever the reaction takes place, there is no loss in the total mass. The total mass of this whole thing is going to remain the same before and after the reaction. So yes, its statement says that whenever a chemical change takes place, the total mass of the reacting substances is exactly equal to the total mass of the products, provided masses are measured under similar conditions. It should not happen that this is under pressure and this is not under pressure. We are measuring everything under similar conditions. In that case, the total mass of the reactants will be the total mass of the products. It can also be further put forth as matter can neither be created nor destroyed during a chemical reaction but changes from one form to another. So matter is not going to be, neither is going to be created nor it is going to be destroyed. So matter is neither created nor destroyed but during a chemical reaction but changes from one form to another. So explanation over here will be mass of A plus mass of B is equal to mass of C plus mass of D over here. So total mass of the reactants is the total mass of the products. So mass of AB is equal to mass of C. So experimental evidence यहाँ पे वो figure में दिया है. It is this way. The Ladot used a H-shaped tube as shown above and introduced a solution of sodium chloride with silver nitrate in the limbs of the tube. Solution BaCl2 and Na2SO4 could also be used in the H-shaped tube in place of NaCl and AgNO3. The tube are then sealed and weighed before the experiment. The solution then mixed with each other by shaking and white precipitate of white silver chloride are obtained. The tube was again weighed after the experiment and the result is that the total mass of the reactants in the H tube before and the total mass of the product in the H tube after is equal. There is only one limitation in this particular thing, and that is that are observed causes, that is for a very high error in experiment. Okay, so observed causes of for a very high Ladot observed causes for a very slight error in the experiment, that is chemical change stored up. A chemical energy stored up in the reactants is released in the form of heat or light. So they say that the energy which is going to be used, the energy that is the heat energy which is going to be used, that heat energy might get converted, or the energy which is going to be given out by the reactants over here, they get converted into heat and light. So that formation of change of energy over there is also going to take place. So it is not just the mass, but it is also the energy which is going to have the changes over here. So accordingly, this we have that hence the mass is converted to energy, and thus mass and energy are considered to be together. So here the main thing is that initially we considered only the mass of this is equal to mass of this, but ये mass में थोड़ा बहुत changes आता है. That is a very slight change which is going to take place, and that is because of the heat energy imparted or heat energy generated or light energy generated. So any kind of an energy change which is going to take place can result into the decreasing or the increasing of mass. Hence, mass and energy both are connected together. Hence, जो पहले स्टेटमेंट ऐसा था that mass is going to neither be, the matter can neither be created nor be destroyed, जो है वो हम लोग थोड़ा चेंज कर देते हैं, and we can say that atoms can neither be created nor destroyed but change from one form to another. So this is about the chapter matter from your chemistry first chapter. You can go through the exercise which is there later on behind and see if you got any doubts and let me know. Okay, so that was the first chapter of chemistry.